Namaste children. I hope you all are safe at home during this lockdown period. We have been sending children various videos prepared by your teachers. We have already started the syllabus for class 10th and we started important modules in the form of your virtual class video lessons for other classes as well, that is from 6 to 9. So if you have any doubts regarding the syllabus or any doubts pertaining to the subject matter, hope you have your all subject teachers numbers. Please do post your doubts and get it clear immediately without any delay. Okay. So well children, today I am going to talk about some introductory material or introductory class for the students of 6 to 10. Now, what is this introductory class? This introductory class basically consists of what exactly the science is. You know children, I wonder if some of your friends ask you, your parents ask you, your relatives might ask you, you have been studying science for the last few years. Maybe you are studying environmental science from class 1. Now you have reached 6, 7, 8, 9, 10 onwards. That means you have studied a lot of science. Then if someone asks you what exactly the science is, can you tell something about science? Are we in a position, are you in a position of explaining? Are you in a position of defining science? That's the call for. So I'm going to discuss about what exactly the science is all about. And then we also talk about the branches of science. Then through those branches of science we will move on obviously to chemistry subject. And then I will give some introductory part of the chemistry which everyone must know before you start anything in chemistry. So this is what some introductory portion which every child should know as far as the science students are concerned. Okay, so let me start with science. What exactly is science? Children, I can give a simple definition for science, like science is a systematic knowledge of facts gained through observation, experimentation, analysis through some evidences. Systematic knowledge of facts on the basis of evidence. Simple. It's also science. But you know, science is not so simple. It includes several domains. So I would like to give you a comprehensive definition of science which consists of 4 components, or I must say 4 important technical terms are there. The entire matter is with you, my dear children. I have already posted this content with the heading, I think, some amazing facts of elements like that. So you will get the introductory part in that material. It's of 6-page content. Please go through that carefully. So before we define what exactly the science is, we must understand these 4 terms or these 4 technical terms or concepts. Okay, first one is the pursuit. Pursuit means in search of something, in search of inventing something, in search of discovering something, in search of finding out some solution, in search of treating some unknown diseases. Like you see, now the whole world is suffering with the attack of the deadly coronavirus. Unfortunately, we don't have medicine for that. Now, across the world, thousands of scientists, thousands of doctors are doing research. They are in the search of finding out a drug or a medicine to prevent this disease, COVID-19 disease. They are in the search. So we are in search of everything. We are in search of several things which makes the human being, to live with comfort. So this is how it goes on. So the first part is the person in search of something. So science is nothing but searching something new, inventing something new, getting solutions, new solutions for some problems in an innovative way, and so on. The second part is application of knowledge. Children, you learned earlier also. You have been learning so many scientific concepts. Okay? You are learning something. You are getting some knowledge. Now, knowledge becomes useless unless you put into practice. So whatever we learn, whatever the knowledge we acquire, we must be in a position to apply. Just now, a few minutes back I said, application of science at industrial level becomes technology. So if we can't apply the learned knowledge, it's of no use studying science or any subject. So the second important part is application of knowledge. Third part is scientific methodology. Whatever you do in science must be systematic. There must be a procedure. There must be some hierarchical steps to be followed. So that those steps which we follow in the process of finding out something new is what exactly is known as scientific methodology. Children, usually scientific methodology involves certain important steps. Like for example, first step is observation. So what do we do after observing? We'll try to compare with others. I observed this, so I'll try to compare this with this, whether it is big or small or heavier or lighter, whatever it may be. So observation, then comparison. That's what we call it as correlation. Then we do some experiments. So observation, comparison or correlation, then experimentation. After we do certain experiments, we get some data, we get some results, and then we'll have to interpret the results, and then we analyze the result. So data interpretation, collection of the data, data interpretation, then analysis of the data. Sometimes we do very, very critical analysis of the data. Then on the basis of the data obtained by one particular researcher, may be repeated by X, Y, Z also, because everyone must get the same result. It's not that you are getting some result in this experiment, in the same experiment, Y scientist is getting some other result, Z scientist is getting some other result. No, that will not be accepted. After the repetition of the experiments, if everyone gets the same data, those who are working on that, then you can establish some facts and rules as well. Rules, principles, etc. This is how rules and principles and laws are created. It's not so easy. It's not that you give any law or any rule or any principle based on your hypothesis. No. That needs evidence. That needs the proof. That needs a repetition. So that's what about these steps which are involved in. Those are the steps which were involved in the scientific methodology. I repeat again: observation, correlation, experimentation, collection of the data, interpretation of the data, analysis of the data, followed by sometimes critical analysis of the data, then repetition of the experiment and checking the cognizance, whether they are all also getting the same result, and then establishing certain facts or rules or principles or laws on the basis of absolute evidences. These are the steps which are involved in scientific methodology. And finally, as I mentioned already, these all must have some evidence. And if you know all these four technical terms which we have used in defining the science, you can better write your own definition, my dear children. If you understand them, you can write your own definition. Anyway, I'll give the integrated, or you can say the comprehensive definition of science using these terms only. So the science is nothing but the pursuit and the application of knowledge and understanding the natural and social world. Natural world means what is all present around us, naturally available things, that's natural world. Then social world means the society, the community. You know, we bring a lot of changes in our community systems. So how communities and social changes are happening, this is all about the science. So the pursuit and application of knowledge and understanding the natural scientific world using or applying the application of knowledge, understanding the natural and social world, following. How you do that? How you do that? How you understand that? How you understand the nature? How you understand the society? You will have to following scientific methodology based on the evidence. Simple. So you can make your own definition. I'll repeat this. Science is the pursuit that is in search of something new, and application of knowledge and understanding natural and social world, following scientific methodology on the basis of evidence. Simple. So this is the comprehensive definition for science. So if somebody asks you, you must tell them. You must know, you must explain them what exactly the science is. It's not so simple that science is, studying botany, zoology, biology, physics, chemistry, not like that. You must know what do we do with science. Okay. So that is all about the definition of science. Then science, branches of science. The science is broadly divided into physical sciences and biological sciences. Physical sciences and biological sciences. Physical sciences includes physics and chemistry. Physics and chemistry. Biological sciences includes botany and zoology. Both botany and zoology together are called biology. Botany deals with the plants and zoology deals with animals. These two branches together are called biology. Also call it as biological sciences. Then physical sciences includes physics and chemistry. Obviously you know that my subject is chemistry, and you all must be eagerly waiting what all we are going to study in chemistry from class 6th onwards. I must tell you children, as you all know that chemistry from 9th to 12th classes is an integrated curriculum. They are all connected to each other. Then studying chemistry suddenly in higher classes is not so easy. So what we are doing in our Prodigy Vidyalaya is that whatever the chemistry that you are going to study from 9th to 12th, 9th class to 12th class, which is very, very important for your any damn competitive examination, we are going to study that part of the chemistry gradually from 6th class onwards in the form of certain modules. So if you have the strong base of the chemistry, obviously you will perform absolutely better when you go to the senior classes. So, I must draw your attention, children, to make you understand how important chemistry is in classes 6 to 10. Just now I said that if you wish to perform well in intermediate education or plus 2 level, we call it as, you must have a strong base of chemistry at school level only, because the syllabus is huge in plus 2 level. Intermediate, if you go to intermediate, the syllabus is a huge syllabus is there. Then you will have to face a lot of competitive examinations as well. So that is one thing. Second, if you are taking science stream does mean, I am talking about intermediate education or plus 2 level. If you are going for biology in intermediate, then you will have to study chemistry and physics. If you are going for paramedical courses, if you are aiming for paramedical courses like physiotherapy, pathology, pharmacy, agricultural BSc, if you are going for paramedical courses, agricultural BSc is of course a different thing, and we have a plain BSc also, where you will be studying biology, physics, chemistry, etc. So, even if you are going for medical courses, paramedical courses, plain BSc, etc., you will have to compulsorily study these two subjects, physics and chemistry. Not only that, if you are going for any technical course, if you are taking mathematics subjects for engineering or ITI, etc., again you will have to study physics and chemistry. If you are going for only commerce classes, commerce stream we call it as, if you are going for commerce stream, that means you are taking CEC or MPC or HEC. CEC means civics, commerce, economics. MPC means mathematics, economics and commerce. HEC means history, economics, commerce. If you are going for such subjects, then you need not to study physics and chemistry. Otherwise, in all science streams, technical and non-technical, medical, paramedical, agricultural, plain physics, engineering, if you are going for any of these branches or streams, you have to study physics and chemistry. So that's why you cannot get rid of chemistry till 12th class unless you are going for commerce stream. And therefore, chemistry is very, very important subject. So now let me tell you what is chemistry. Now if somebody asks you, obviously just like science, if somebody asks you what is chemistry, you are studying some chemistry. In chemistry there are chapters like atomic structure, chemical bonding, classification of elements. There are some such lessons. So teachers start teaching chemistry lessons, and maybe sometimes any of your friend or anyone may ask you, can you define what is chemistry? You must know that, children. You must know. And once you know what exactly the meaning of chemistry in a broader perspective, you get interest in studying that particular subject. All these subjects like physical sciences, biological sciences, which are the part of science, are very, very interesting. Why, I must tell you. Science is indeed a subject of curiosity. Science is said to be the subject of curiosity. What does it mean? You will try to know, why is this happening? Why is that happening? Why this is green in color? Why this is colorless or white? Why this board is hard? It's hard. This is hard, but I can break this chalk into pieces. So some of the substances are hard, some of the substances are soft. You get so many questions in your mind. Why the sky is blue? Why the seawater is salty? Why the seawater is blue in color, whereas river water is colorless? How clouds are formed? How the earth is formed? How the water is formed? All these kind of questions. It's so many questions will come up. So that interest, that kind of interest if we have, finding out why, how, when does this happen and so on. So that means we have certain scientific temperament. That's what is called scientific temperament. A child who is always asking such questions, you must ask yourself, is also a kind of curiosity. Having curiosity, that means you have some scientific aptitude. Everyone should have that. Then you will take obviously interest in science and you will perform well in science. So you must be curious, because science is a subject of curiosity. It has facts, it has evidences, it has proof, it has experiments to do. It's not based on assumptions simply. So it's a very interesting subject. So, coming back to the definition of chemistry, which you all must know, because you are going to study the chapters of chemistry, means you must know what exactly the chemistry is in broader sense. I'll tell you, the defining chemistry is very, very, very simple in comparison to the definition of science. Look, in chemistry, again there are three terms here. One is composition, second is properties, and third one is transformation. I'll tell you what these terms are. Then if you understand these terms, we use these three terms to define chemistry. It is not that I am giving the definition of science first, delivering the statement of science first, or dictating the statement of science first and then I explain. No, I will not do that. You can make your own statement once you understand the terms involved in the definition. So, first one is composition. Composition means, for example, what is this made of? What must be the structure of the substance? What must be the composition? That means, what must be the structure of the substance? What must be the chemical formula of the substance? What must be the weight of the substance? And so on. If you talk about all these things, that is nothing but composition. Structure, formula, name, and its other features as well. Then second, properties. Properties means, these two substances we have, duster and piece of chalk. There are differences between these two. How it is hard, it is comparatively less hard. I cannot break easily the duster into pieces. I can break easily the chalk into pieces. Its color is different, its color is different. Its weight will be different, its weight is different. It is made of some substance, it is made of some substance. It is made of some elements, it is made of some elements. Like that, if you know the properties, color, weight, their hardness, their conductivity, their melting point, there are so many properties for substances. That's nothing but properties. Properties. How do they look like? What are they? Whether they are hard or soft, and so on and so forth. The last one is transformation. Now you see, I can burn this material. Basically, this is made of wood. Wood is nothing but cellulose. In cellulose, I'll tell you, there are three elements, carbon, hydrogen and oxygen. Together will form cellulose material, which is in the form of wood. Now if I burn this, what what will happen, you know? Oxygen and hydrogen will get separated. They will be entering into the atmosphere in the form of water vapor and carbon dioxide, leaving behind only carbon in the form of ash. And that's the reason why when you burn this, you will get ash. This is how it is undergoing some change, and that change from one form to another form is nothing but transformation. Now this is nothing but calcium sulfate. This is nothing but calcium sulfate. Now I can treat this calcium sulfate with a substance so that it can change into another substance. So the third one is related to the chemical substances, how they undergo transformation from one form to another form. So using these three terms, I can now define what is chemistry. So chemistry is obviously the branch of science that deals with the study of composition of what? Substances. Composition and properties of substances, okay, and how they undergo transformation from one form to another. That's all about chemistry. Again, I am repeating. I am making the sentence. You know, I am not remembering or something like that. You also not supposed to cram or do rote learning. Understand and compile those words in the form of a meaningful statement. You will never forget that. So chemistry is a branch of science that deals with the study of composition, properties, and how they undergo transformation from one form to another. That's it. That is what is all about chemistry. Now children, before we start with any chapter of chemistry, we must know some basic idea about few technical terms pertaining to chemistry. See, we all know about universe. You know, universe. Universe means Vishwam in Telugu. Universe consists of what? There are only two things present in universe. One is matter and another is energy. Of course, we can convert matter into energy. In certain forms, energy may be converted back into, in rare cases, we can convert energy back into the matter, but always matter can be easily converted to energy. Like for example, fuel, petrol, diesel, kerosene, etc. When you burn them, what happens? They in turn produce heat energy, and that heat energy is converted into mechanical energy, and hence the vehicles move. So matter changes to energy, but the whole universe is what we have in the universe is matter and energy. Energy, you know, kinetic energy, potential energy, heat energy, and so many forms of energy like electrical energy and so on. Now what is matter now? You all know children, maybe except class 5 students moved to class 6, they might not be, I don't know, but rest of the classes we have already discussed about matter. Very simple to understand what is matter. That means, once again I am coming back to the universe. If you exclude energy, whatever is present in the universe, like water, earth, moon, sun, planets, everything is made of matter. Excluding energy, everything is made of matter. That constitute universe. Vishnu. Now what is matter? Very simple. Matter is anything. It may be duster, it may be chalk, it may be board, it may be shirt, it may be, metals, they may be non-metals, water, liquids, solids, gases, anything. occupies some space. Look, this is occupying some space. I cannot put anything else in place of duster unless I remove this from here. At this place I cannot put this. It is occupying some space. This is also occupying some space. The board is occupying some space. Gases are occupying some space. So anything that occupies space and has mass. This is also having some mass. Chalk is also having mass. Of course, the mass of this duster is more than the mass of the chalk. That's it. But both of them have some mass. So anything that occupies some space and has mass. That means when you are defining matter, there are only two terms which you must know. One is space and another is mass. So anything that occupies some space and has mass is nothing but matter. Clear, children? So easy to understand the matter is anything that occupies space and has some mass is nothing but matter. Now the question arises, what does constitute this matter? What is there in this matter? Are all the matters are same? This is also matter, this is also matter. Or are these matters are same? Answer is no. Why they are not same? They must have been made of different substances. So what are those substances? What is the constituents of matter? Children, you know, our body is made of organ systems. An animal is considered as an organism. We are also organisms, living organisms. An organism consists of organ systems like digestive system, nervous system, respiratory system, circulatory system, etc. Now each organ system consists of different types of tissues, and different types of tissues consist of cells. Now if you go in a reverse order, cells constitute tissues, tissues constitute organs, organs together constitute an organism. Okay? So organs constitute organ system. Sorry, one more step is there. I am coming back. Cells constitute tissues, tissues constitute organs, organs constitute organ systems like respiratory, circulatory organ systems, and all these organ systems together constitute an organism. Maybe an elephant, maybe a human being, maybe an ant, maybe anything. So similarly, we must understand what does the matter constitutes. What is there in the matter? Everything is considered to be matter. Anything that occupies some space and has mass is considered matter. But what does it consist of? Let me tell you, children, that the matter consists of elements, or elements constitute matter. Elements constitute matter. There are 118 elements. That means, I'll tell you, very simple to understand. You are having gold. Are you wearing gold? Perhaps you must be wearing gold. Gold is an element. Iron is an element. Aluminum is an element. These are of course said to be metallic elements. There are some non-metallic elements. Other elements like carbon, nitrogen. I'll be writing here, that's better. It is all there in your material, but still it's better I write. Gold, its symbol is A. Iron, its symbol is Fe. Then aluminium, its symbol is Al. Okay. Lithium, its symbol is Li. Carbon, symbol is C. Sulfur, phosphorus, oxygen, nitrogen, etc. How many such elements are there? 118 elements are there. That means as of now, maybe new elements may be discovered in future. Earlier, in 90s, the number was very less. It was around 72 elements. Then thereafter, some new elements were synthesized, especially by Dr. Marie Curie and Pierre Curie. Curie family members, they have they have synthesized new elements. So as of now, there are 118 elements. So the matter is made of these elements. Okay? Or group of elements. The matter is made of these, either directly these elements or combination of these elements. For example, you know hydrogen, you know oxygen, hydrogen and oxygen. If two hydrogens and one oxygen combine, it forms a compound named water. I am using the word atom, that also I am coming to. So an element consists of similar type of atoms. Easy to understand, children. You need not to be panic when you get new technical terms in chemistry. But one thing is for sure, the subject chemistry is completely conceptual. If you understand this, you can understand this easily. If you understand this, you can understand this easily. If you understand this, you can understand the structure easily. If you understand the structure, you can understand the properties of elements easily. If you don't understand this, you don't understand this, and so on. So be careful. Chemistry is absolutely a conceptual subject. At times you need to use your imagination power. You need to use your imagination power. Like for example, when you talk about atoms, I'll say that atom consists of centrally located nucleus having positively charged protons and neutrons in it, surrounded by negatively charged electrons revolving around it continuously. You know, you can't go and see how the planets are moving around the sun or the moon. We imagine. When I say that, they are revolving around the nucleus in circular orbit, then you imagine in this way. So if this is the nucleus, it is the circular orbit. Orbit means path. Orbit means path. When I say that no, they are also revolving around the nucleus in elliptical orbit. This is the path now. This is nothing but elliptical path. So we need to imagine several concepts in chemistry. So imagination power is very, very important, because you need to associate concept A with B with your imagination. Concept B with C with your imagination. Certainly you can better understand. It's very easy to understand chemistry, but there must be a link between each and everything. There is an absolute link between each and everything, therefore you cannot miss this understanding, and you cannot afford to understand this one like that. So, an element, for example, hydrogen. Hydrogen element, carbon element, sulfur element, these are non-metallic elements, these are metallic elements. You take any one, metal, non-metal, semi-metal, whatever it may be. If I talk about hydrogen element consists of what atoms? Hydrogen atoms. Carbon element consists of what? Carbon atoms. Phosphor element consists of what? Phosphor atoms. An element consists of the similar type of atoms. So, what are the building blocks of the matter? Finally, they are atoms. Now, are all the atoms same? No. They depend on the element. If the material is made of gold, it is shining, hard, doesn't react easily with some chemicals. Whereas iron metal, it is different element. It is different element. It easily gets corroded. You just keep a freshly prepared iron rod on your terrace. Within 25 to 30 days, it gets a layer of that rod gets corrodes. That's what you call it as rusting of iron. Okay, even silver. There is a metal named silver, Ag. It gets faded immediately after a few minutes of exposure to the atmosphere. There are some elements which are reactive, there are some elements which are not reactive, there are some elements which are very hard, some elements which are soft, there are some elements which exist in gaseous state, some elements which exist in liquid state, for example bromine, mercury. Mercury is a metallic element which exists in liquid state. Usually metals are hard, brittle, sonorous, that's what you have been studying about. But there are some metals which exist in liquid state also. One is mercury, which already you know. Then there is an element, there is a metal named gallium. The moment you take it on your palm, it melts. And if you keep it on this, for example, it will again solidify. That means the gallium metal melts at our body temperature. At our body temperature, 98.6 Fahrenheit degrees. Okay, so the matter is made of elements. There are 118 elements. Each element consists of the similar type of atoms. Similar type of atoms. Now, to understand and know the elements, as we said that there are 118 elements, the scientists gave different symbols for them, and those symbols I have written here. See, hydrogen. First element I have written is hydrogen. Now the symbol given for hydrogen is H. Another element named carbon. The symbol given is capital C. Always they start the symbol with capital letter. In case if they need, they use small letter also. I'll tell you why. As I said, there are 118 elements. Now, one element name is carbon, which is of course a non-metal. I have written here. There is another element name as calcium. Another element named cadmium. There is another element named cobalt. Another element named chromium. Now see, in all these elements, the starting letter is C. Now already for carbon we gave the symbol C. Now we cannot afford to give the same symbol for other elements. Therefore what they did, in case of calcium, they have used capital letter C followed by the small letter A that follows C in its spelling, calcium. In case of cadmium, what they did, C with D, it is cadmium. In case of cobalt, what they did, is C, capital C with small o, it is cobalt. In case of chromium, since R is there, the C with R. Okay, like that. So, first letter is always capital, followed by this small letter, depending upon the spelling of the name of the element. Now, there are some elements where they have used Latin names for giving symbols. There are some examples here. Look, aluminum as it is, A followed by L, aluminium, A followed by L is correct. Aluminium or aluminum, both are correct. Okay. Lithium, it is again a metal, L-I-T-H-I-U-M, lithium. Capital letter followed by small letter. Because there are other elements like lawrencium, etc. So again, L repeats. Therefore, lithium we write L followed by small I. Now look at this AU. This is named as AU is named as gold. But why A and U? The Latin name of gold is actually Arum. Arum. So they have taken first letter of the Latin name A as capital, followed by the small letter U, and therefore the symbol of gold is not GO, it is AU, because its symbol has been taken from its Latin name Arum. Similarly, you see Fe, its Latin name is Ferrum. But actual name is iron, but its symbol is taken from ferrum, F followed by E, ferrum. So this is how to differentiate, to understand the differences, to be able to identify various elements present in different substances. They gave symbols for each and every element. So there are 118 elements and 118 symbols are there. So children, you need not to be panic of how we can learn 118 elements, their symbols and all. No, you need not to be panic, because gradually you will be learning. Maybe initial stage you can learn 20 elements with their symbols, then 30 elements, then 40 elements and so on. So you need not to learn all of them together. If you get interest, you can do it. No issues. You have enough time at home, children. You keep on going through the material. I have given all 118 elements, symbols, the names, and I also gave the atomic number of the element in the first column. There are 3 columns in that list. First column is atomic number, second column is the name of this element, and third column, second column the symbol, and third column I gave the name. So 118 elements are there in your material. Please go through that. Now I am coming back to the last term which we have used, atom. And I also told you that the building blocks of the matter is nothing but atoms. Just like cells are the basic unit of life. The cell is the basic unit of life, we say. Similarly, atom is the building block of the matter. The matter is made of tiny particles, small particles. Small particles are known as atoms. Atoms are, what is atom? Atom is the smallest particle of the matter. And this atom is subdivided into some subatomic particles. So children, I'll be briefly discussing about in the next just few minutes all about the atom and its atomic number and mass number. Atomic number and mass number. I'll give you the details in just few minutes. Okay. So children, as we all know that there are 118 elements. Now every element has similar type of atoms. Every element has similar type of atoms. So an element named hydrogen. So hydrogen consists of which atoms? Hydrogen atoms. What is the symbol of hydrogen? H. Then there is another element, helium. It is known as He. Helium, helium. So helium consists of helium atoms. Hydrogen consists of hydrogen atoms. Oxygen consists of oxygen atoms. For example, I take O for oxygen. Oxygen consists of oxygen atoms. So how does this atom looks like? What does this atom further consist of? As we just discussed that atoms can be further subdivided into subatomic particles. For example, in hydrogen, in case of hydrogen, the atoms look like this. The atom of hydrogen look like this, see. Just like the cell, plant cell or animal cell, consists of centrally located nucleus. Okay? And it has nucleoplasm within that. Okay? Similarly, the atom of any element consists of centrally located nucleus. It is named as nucleus. Centrally located nucleus. Surrounded by negatively charged electrons revolving around the nucleus in certain paths. And the path may be, this is the path actually, I am drawing some path. And this may be a circular path where you can find this electron which is revolving. Electrons cannot stop revolving. If electron tries to take rest, okay, it doesn't happen. What will happen? The positively charged nucleus will attract the electron and the electrons will fall down into the nucleus and the atom gets collapsed. But it never happens. So, what are there in the nucleus? I'll tell you now. In the nucleus you have positively charged protons. Positively charged protons. And around the nucleus, positively charged protons and neutral neutrons. Positively charged protons and neutrons. Protons which are positively charged. I am coming to this helium. It's a small element, so I am drawing helium. This is the nucleus of helium. Okay, it is having 2 protons and 2 neutrons. Okay, I have written protons. Here I have not written neutrons here because hydrogen is only the element which doesn't have neutrons in the nucleus. Therefore, I have written only protons which are positively charged, and this is electron. And if you come to helium, there are 2 protons in the nucleus. This is the nucleus of helium. Okay? How many neutrons are there? 2 neutrons are there. 2 neutrons. Now children, neutrons are chargeless. There is no charge. Neutrons are neutral in nature. Neutral means no charge. Protons are positively charged. Neutrons are chargeless. So what will be the total charge of the nucleus? Yes, obviously it will be positive because protons are positively charged, neutrons are chargeless. So the overall charge of the nucleus will be positive. Now where are the electrons? Electrons revolve around the nucleus in certain circular orbits. You know, what is this I draw? This is not something, the part of the atom. This is simply the path. In this path, you will have electrons. So, in case of helium, you will have 2 electrons. In case of hydrogen, you have only 1 electron. In case of oxygen, you have 8 electrons. In case of sulfur, you have 16 electrons around the nucleus. Okay, so this is how from atom to atom, from element to element, number of electrons and protons will be, protons and neutrons will be different. And that is the reason why these elements behave differently. different from helium. You know, these two elements have absolutely no comparison. Hydrogen is the lightest and highly combustible gas. Very, very reactive gas. Highly combustible. Hydrogen bomb can be prepared for making a huge explosion. Whereas helium is absolutely less reactive. Even if you do anything to helium, it doesn't react. It is so stable. It is so stable. So this is how the elements are different from each other, or the atoms of different elements have different properties because of the reason that they have differences in the structure of their atoms. When I say the structure, the number of protons, neutrons and electrons, that's it. Now this is all I can say, that this is the structure of helium atom. This is the structure of hydrogen atom. Hydrogen atom is having 1 electron and 1 proton, 0 neutrons. Hydrogen has 0 neutrons. This is only the element which has 0 number of neutrons. Rest all have the number of neutrons. Oxygen, I said, they have 8 protons and 8 neutrons and 8 electrons. Now here, the last point I would like to mention, a scientist named Moseley. A scientist named Moseley is a very interesting scientist. He was working with his, professor, guide, Rutherford. He will be studying Rutherford's model of atom later on. So he was also the student of, one of the students of Rutherford, just like Bohr. Some students knows, that's why I am mentioning. Do you know, children, he was such a great scientist. He was the person who introduced atomic number. So the atomic number was introduced by Moseley. Atomic number was introduced by Moseley. I'll tell you one amazing fact about Moseley. Had Moseley been alive for more than 30 years, he must have got 100% Nobel Prize. Nobody on this planet can discard this, because he has introduced such a wonderful information, that is atomic number. Now he could not receive Nobel Prize because unfortunately he was not alive after 23 years only. And you will be amazed to know the fact why he lost his life at the age of 23, because of the reason that he joined army and lost his life during his Second World War. He is a British scientist. He was a British scientist. He joined British army, leaving his scientific research. Imagine his patriotism towards his country. He lost his life. Otherwise, certainly he would have got a Nobel Prize for wonderful introduction of atomic number for the elements, without which it is very difficult to understand the structure of the atom and their properties. It is because of the atomic number we understand so many things. Now, atomic number of hydrogen is 1 because there is only 1 proton. So, atomic number introduced by Moseley, whose symbol is given as Z. Atomic number, symbol of atomic number is Z. Okay? Z is equal to number of protons. number of protons. Atomic number is symbolized by Z, and this is nothing but number of protons. Now this atomic number is also equal to number of electrons, but under one condition, only when the atom is neutral. Only when the atom is neutral. If the atom becomes an ion, positively charged or negatively charged ion, they are called cations and anions, then it will not be equal to atomic number. Therefore, remember, atomic number is always the number of protons. Atomic number is always the number of protons. Now, there is another term, mass number. What is this mass number? Mass number is symbolized by capital A. Mass number is symbolized by capital A. Now, mass number is equals to number of protons plus number of neutrons. Number of protons plus number of neutrons. Where are these protons and neutrons present, children? They are present in the nucleus of any atom of an element. Okay? So an element consists of similar type of atoms. If more substance you take, you will have more elements. If less substance you take, you have less elements. Now, an element consists of similar type of atoms. And now, what are there within the atom? You have a centrally located nucleus, and what nucleus consists of protons and neutrons. Okay? Now, how many protons you have in the atom of helium? 2 protons. So I am writing here A equals to, I am calculating the mass number of helium now. Calculating the mass number of helium. So mass number of helium, mass number A of helium equals to, how many protons are there? 2 protons. So 2 plus, how many neutrons are there which are chargeless? 2. So 2 plus 2 is 4. So the mass number of helium is 4. Mass number of helium is 4. What is the symbol of helium? He. Okay. Now, atomic number, what is atomic number? Atomic number is number of protons. So how many protons are there in the helium? 2 protons. So that number is written here. So atomic number as a subscript on left to the symbol of any element. Now what do we write here? Mass number. It is 4. Like this. 2He4. So this is atomic number. This is mass number. See, mass number is different from atomic mass. That we will discuss later on. But here simply A stands for mass number is just the sum of the protons plus neutrons. We don't consider electrons because electrons are so small and their mass is considered to be negligible. So that's the reason why when we are calculating mass number, though there are 2 more electrons in the atom of helium, we have not included. We have included only protons plus neutrons. So the mass number is calculated by adding protons and neutrons, but not the electrons. Electrons are considered to be having very less mass, which is considered to be negligible. So this is how the atoms of elements is all about. So children, that's all for today. I would like to sign off here. So please go through the content. If you have any doubts, please post your doubt in the form of a question. Thank you. Wish you all the best.